This is lesson 27 for 7th grade, module 6 on real-world volume problems. So I will warn you that this work for each of these problems is quite a lot. So if you want to get out a piece of lined paper and do it on that and then attach that to the worksheet, that's fine. It will fit if you write small, but just letting you know ahead of time if you wanted to stop the video and go get some scratch paper to put this all on. So we have our first problem here. A swimming pool holds 10,000 feet cubed of water when it's filled. John and Ann want to fill the pool with a garden hose. The garden hose can fill a 5-gallon bucket in 30 seconds. If each foot is about 7.5 gallons, find the flow rate of the garden hose in gallons per minute and in cubic feet per minute. How long will it take to fill the pool with a garden hose? If the hose is turned on Monday at 8 a.m., approximately when will the pool be finally filled? So this is using one of your standard hoses that you probably all have in your backyards. And I'm gonna be honest, it's probably not the best means to put water in your pool because it will take a while. You have to think this hose is rather small around, so only so much water can go through it. And if you have a pool that can hold up to 10,000 cubic feet of water, then you're looking at taking a little while to get this pool filled up. So what we're going to do is kind of walk through that. So let's write down some information that we do have so far. I'm going to talk about the hose first. They mentioned that the hose can do 5 gallons. In 30 seconds. Well, I'm going to convert that to minutes because everything mentioned here is in minutes, not in seconds. So they want to know how long it'll take in minutes. So we're going to convert this into minutes. All right, so I'm going to put 5 over 30. And I'm going to set that equal to the proportion of what would that be in 60 seconds? 60 seconds being the 1 minute. Okay, you can cross multiply here, and you're going to get 30x. 5 times 60 gives me 300. We're going to divide out the 30 so we can get the x by itself. And the x equals 10 gallons. So I can use this hose, and it'll go 10 gallons in 1 minute. All right. So I needed that conversion just so I can keep going. Now, if we want to convert this to cubic feet, all right, because again, this is talking about cubic feet here. Okay, it's not in gallons, it's in cubic feet. So I need to convert again. So we're going to say convert to cubic feet. All right, when I convert to cubic feet, I'm going to say 10 gallons times 1 cubic foot is equal to 7.5 gallons. That's just the conversion, okay? Well, this is written in a fraction form. So when you have fractions, it just means to divide. So I'm going to do 10 divided by 7.5, and I'm going to get 1.3 feet cubed, and that 3 is going to keep repeating. So let's go ahead and just say 1 1/3 feet cube per 1 minute. All right, so I can do 1 1/3 feet, cubic feet, I should say, in 1 minute. So now we have some information. We can start putting together an actual formula. So the blue was just some information. Now we're going to start solving. I have a 10,000 cubic foot pool. And if I use my ratio down here that I can do 1 1/3 cubic feet per minute, how long will that take? So I'm going to go ahead and convert this to 10,000. I'm going to get rid of that fraction at the bottom. I'm just going to say 1 3/4. All right, so if I multiply that straight across, I get 30,000 divided by 4, which will give me 7,500 minutes. Okay, so I will need 7,500 minutes in order to fill this pool. So let's talk about that. Let's talk about converting from days and hours. What does that look like in terms of days and hours? So 7,500, let's go ahead and divide that by 60. And I get 125 hours. Okay, 125 hours is the same thing as 5 days. So if we started this on Monday at 8 a.m., and we go 125 hours from that point, then pool will be filled by Saturday. So you can see this is going to run for a long time. Saturday by 1 p.m. And that's doing 125 hours from 8 a.m. on Monday. So 5 days, and then the time difference between 8 a.m. and the full 125 hours. So we have some things we need to box here. We're going to box this answer here. We're going to box, obviously, Saturday by 1 p.m. And we're going to box our conversion here of 10 gallons per minute, and then this one here. So this one has several answers I'll be looking for to give you full credit. All right, let's look at example 2. Example 2 says a square pipe. You may think of like a rectangular prism kind of shape. So think of like a pipe that has a hole in the center, but the outside is in the shape of a rectangle. With the dimensions of a 2 by 2, has water flowing through it at a flow speed of 3 feet per second. The water flows into a pool in the shape of a right triangular prism, with a base in the shape of a right isosceles triangle, with legs that are each 5 feet in length. How long will it take the water to reach the depth of 4 feet? All right, so the first thing I'm going to do is kind of draw a makeshift of that pipe. All right, so here's my pipe. It's a 2 by 2, and it flows. The water is going through it at 3 feet per second. All right. So we can even put here water flow is 3 feet per second. All right. Now I'm going to go ahead and convert this. That 2 inches is 1/6 of a foot. So instead of doing 2 by 2, because those are in inches, I need it to be in feet. I'm going to say 1/6 times 1/6 times 3. That's going to give me 1 over 36 times 3 gives me 3 over 36. Okay, I can reduce that to 1 over 12. So 1 cubic foot in 12 seconds. That's what that answer means. Now I'm going to take that answer and I'm going to convert it to minutes. And that's because it wants to know all of this in terms of minutes. So convert to minutes. So I'm going to take 1/12 for 1 second equals 60 seconds in 1 minute. All right, so when I go ahead and cancel this or just multiply straight across, I wind up getting 60 over 12 because you wind up flipping that around, doing its reciprocal. And 12 goes into 65. So this is 5 cubic feet in 1 minute. Now, we want to know how long will it take to reach that 4 feet. So let's say reaching 4 feet. I'm going to underline all my little sections here. There we go. We're going to say, because it's a triangular prism, it says it right there. We're not going to do length times width times height. We're going to do half the length times the width times the height. So that would be half of 5 times 5 times, whoops, I guess I just need to do the parenthesis, times 4. All right, and this gives me 1/2 times 100, and then half of 100 is 50 cubic feet. All right, now it says that the legs are 5 feet in length. So we're going to say 50 divided by 5. So therefore, it's going to be 10 minutes for 4 feet. All right, and that's it. Let's look at exercise 1. So on exercise 1, I'm going to give myself some more room here and move that screen down. A park fountain is about to be turned on in the spring after having been off all winter long. The fountain flows out of the top level and into the bottom level until both are full, at which point the water is just recycled from the top to the bottom through an internal pipe. The outer wall of the top level, a right square prism, is 5 feet in length, with a thickness of the stone being between the outer and inner wall is 1 foot, and the depth is 1 foot. The bottom level, also a right square prism, has an outer wall of 11 feet long, with a 2 foot thickness between the outer and inner wall of the depth of 2 feet. Water flows through a 3" by 3" square pipe into the top level of the fountain at a flow speed of 4 feet per second. Approximately how long will it take for both levels of the fountain to fill completely? All right. So the first thing I would do is let's find the volume of the smaller one up here on the top. So we're going to say volume of the top. The volume of the top is going to be a 3 by 3 by 1. And that's because we're going to look at, you have 3 going across this way, 1 plus 2 is going to give you the 3. So we're going to say 3 by 3 by 1. And that's including all the stuff on the top. So the 1 by 2, the 1 by 2 again, and then the 1 in height. So this is going to give me 9 feet cubed. Now let's find the volume of the bottoms. Now the volume of the bottom, we have 5 here. We're going to take 5 and plus the 2, and we're going to get 7. So this is a 5 by 5, and this is a 2 by 2, so that's going to be 2 7s. 7 times 7, and then we're going to times it by the 2 for the thickness going across. 7 times 7 is 49, times 2 is 98. Now I'm also going to take that measurement and subtract it from the other amount, because it's not going to fill up the outside, it's going to fill up the inside of the fountain. So I am going to take away, first let me find my volume, of a 5 by 5 by 2. And that's going to give me 50. So now I'm going to combine these two into 98 minus 50, and that will give me 48 feet cubed. All right, so what we have done so far is we found the volume of the top parts, and then the volume of the bottoms, going around the bottoms, and then we subtracted, because we subtracted this whole bottom by what was created by this little box here on the top inside of it. Because there's not going to be water going through this box. It's going to go around the outside, and then it's going to fill up this inside hole as well. That all comes to 48 cubic feet. Now, if we take 9 take this answer up here, we say 9 plus our answer here of 48. We add those together, we get a grand total of 57 cubic feet. All right, now let's talk about volume in feet. And that's because they're using inches here. And we can't have this pipe in terms of inches if we're filling up in cubic feet. So 3 inches is 1/4 of a foot. So we're going to say 1/4 times 1/4. And this is talking about that square pipe. And we're going to times that by 4 because it's 4 feet per second. And we get 1/4 cubic feet as my answer there, which means it fills up at 1 cubic foot in 4 seconds. So this is talking about the pipe. However, everything is not in seconds, everything is in minutes. So when we talk about minutes, all right? So I'm gonna switch colors here because my work's getting kind of crazy. So I'm gonna come over here and I'm gonna say we're gonna now convert to minutes. I'm gonna say 1/4 over 1 second. And this is feet cubed times 60 seconds for 1 minute. Now, I would take the reciprocal of 1/4, making it 4 over 1, and then multiply that across. So that winds up being 60 over 4, because you actually divide. And that'll give me 15 feet cubed in 1 minute. So the pipe is actually flowing at 15 cubic feet in 1 minute. So how long will it take to fill both? So I'm going to put down here, to fill both, we're going to take 57, our answer right here. We're going to divide that by the flow rate of 15. And that'll leave us with 3.8 minutes. So about 4 minutes, and the fountain will be completely filled, and then just recycling the water back and forth. All right, let's go ahead and look at the next one. This next one, I'm going to start it off for you guys, and then you guys are going to wrap it up and finish it for me. So we have a decorative bathroom faucet, has a 3-inch by 3-inch square pipe that flows into the basin in the shape of an isosceles trapezoid prism, like the one shown in the diagram. If it takes 1 minute and 20 seconds to fill the basin completely, what is the approximate speed of water flowing from the faucet in feet per second? All right, so the first thing let's do is find the volume. So I'm going to say volume of the basin. And that's going to be 1/2, because it's triangular, of the length times width times height. So we're going to take 1/2. We're going to times that by this 3 plus this 15. That's going to be your length. So I'm just going to go ahead and write that out. 3 plus 15, so you know where I'm getting those numbers from. Times my width, here is 10. This is my width. Times my height, right here, of 4.5. So I wind up with 1/2 times 18 times 10 times 4.5. Combine these two and I get 180 times 4.5. Combine those two and I get 810. Now bring down my 1/2. If I take half of 810, I have 405 inches cubed. So that is my volume for the basin. Now I want to convert. I'm going to convert this to cubic feet. So I'm going to say 405 inches cubed, and I convert that, that's going to be 1 cubic foot for 1,728 inches cubed, and that's just the conversion you need to know, I guess. Not something we typically memorize. We're going to multiply this, and we get 405 over 1,728. All right. This is going to give me a long decimal when you do it on the calculator. I'll just show you real quick. I'm going to grab my calculator. There we go. I'm going to say 405 divided by 1,728. All right, so we're going to write that whole thing down. We're going to say 0.234375 feet cubed. But that doesn't really help me much. That's the conversion, but that doesn't really help me much as far as what is the approximate speed that this is going to fill up. So it did say that my faucet was a 3-inch by 3-inch. So I'm going to say 3 times 3 times some number, some rate of seconds. All right. I'm going to go ahead and convert that. 3 inches is the same as 1/4 of a foot. So I'm going to say 1/4 times 1/4 times S instead of this. So I'm just going to put an arrow there. So it's not necessarily that it equals. I'm changing it over to feet. So when we do 1/4 times 1/4 times seconds, I get this. So this is what this is basically saying. All right, what is this then calculated out to for feet per second? That's going to be 3.75 feet per second. All right, so I actually wound up doing the whole thing for you because as I was walking through it, I knew there was going to be parts that you missed, but you want to make sure that you take good notes here so that you can understand how to do a problem similar to this on the test. All right, that ends this video tutorial.